Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends, welcome back to the sessions of computer networks. The last session we discussed about delays and link efficiency, and the link efficiency parameters also we learned, which are mainly effective, that is TP and TT. If distance is increased, then TP will be proportionately increased. When TP is proportionately increased, waiting time is also being increased and it affects the link efficiency, so channel efficiency is going to be down. So in order to have good link efficiency, we need to have the balancing factor of your useful time and your total time. Therefore, the throughput, which also depends upon link efficiency. So what is the throughput? We know the throughput is nothing but link efficiency, which depends upon bandwidth. Okay friends, and throughput can also be written in such a way, if at all link efficiency you don't know, then throughput equal to link efficiency into bandwidth when bandwidth is available. And now the other one is throughput equal to total data size divided by total time is when you don't know bandwidth. If bandwidth is available, you go to the first equation. If bandwidth is not available, you go to the second equation. Okay. Now, if I am saying, for example, Tt is equal to 10 ms time and Tp is equal to 100 ms time and bandwidth is equal to 1 Mbps, he is asking what is link efficiency, comma, throughput. So the solution is link efficiency is nothing but useful time divided by total. So 10 ms by 210 ms, that equal to 1 by 21. Why 210 ms? Tt plus double of your Tp. Double of your Tp is 200 and Tt is 10. It is 210 ms. Now you want throughput now. Throughput is nothing but, here bandwidth is mentioned, so I can take 1 by 21 into your bandwidth is 1 Mbps. So this is your throughput equation. Okay friends, so these are the very important questions you may frequently get in the examination. What is the link efficiency, what is the throughput, and what is the transmission time, and what is the propagation time. Okay friends, just copy this. Now after this we will learn one more important parameter like throughput. We have one more important parameter that we see. So sometime throughput is also known as good put. Understand? So both are same. And one more, actual transfer rates, that is also known as throughput only. Okay, let's copy this. Yeah. Well, friends, our next equation is volume of the pipe. This is also known as bandwidth delay product, and this is also known as number of bits fit in the channel. Okay, what is the meaning of this? If I am taking bandwidth is equal to 1 bit per second. What is the meaning of 1 bit per second? 1 bit is transmitted at 1 second. That means you take a pipe here. When sender inject 1 bit, this 1 bit is out. After 1 second, 1 bit is out. That's the meaning. If I am saying, for example, bandwidth is equal to 10 bits per second, which means per second I can inject how many bits? 10 bits. Therefore, after 1 second, 10 bits are out. If I am saying bandwidth is equal to 1 bit per second, TP is equal to 10 seconds. So now he is asking you to find what is volume of the pipe. The volume of the pipe is nothing but you take a one pipe which has got sender insets 1 bit, and this bit takes how much time to come out? 10 seconds. But earlier, within 1 second the bit is coming out. Within 1 second the bit is coming out. So you want me to give that? I will give TP is equal to 1 second. TP is equal to 1 second. Now you see, 1 bit I have injected. This bit takes how much time to come out from the channel? Is 10s per bit. Therefore, what happened? The length of the pipe is equal to increased. Why? This bit is carry forwarding next. During this, if you observe carefully, the sender capacity is equal to how much? 1 bit he will inject for every second. But that bit is moving. It takes 10 seconds to come out of the queue. In the meanwhile, sender is not being idle. What he will send? He will keep on sending the data. Therefore, what will happen? How many bits for 10 seconds is equal to 10 bits. Why 10 bits? I will show you. Just copy this. The bandwidth delay product is ultimately depends upon bandwidth and end-to-end delay. What is it and what is the product, we will see after this diagram. Copy this. Yeah. Well, friends, now we will see what is the meaning of bandwidth delay product. So now listen, bandwidth delay product BWP is nothing but bandwidth product is nothing but multiply with end-to-end delay. What is end-to-end delay? The end-to-end delay is nothing but TP only. Okay. Therefore, BWDP for half duplex is equal to bandwidth into TP. BWDP for full duplex equal to BW into 2 into TP. Why? Because both sides can send the data, therefore pipe is equal to very vast. So using that, how come it is a 10 bits and how come it is a 10 bits, we would like to see now. So as I am saying like this, for example is TP is equal to 10 seconds and bandwidth is equal to 1 bit per second. So I am saying full duplex channel. So how many bits? Bandwidth into 2 into TP. That is equal to 1 bit per second multiplied by 2 into 10s. Therefore, it is 20 bits. If at all it is off duplex channel, then what will happen? Bandwidth, just you simply multiply with the TP. So 1 bit per second into 10s. So it goes how many? 10 bits. Now, which means what is the ideology here? The ideology or mechanism here is like this. So my capacity is a 1 bit per second. Therefore, you take a channel. This channel has 10 slots. Okay. Sender sends bit 1 with is bandwidth 1 bit per second. That means every second he will inject bit into that. But that bit cannot be out immediately because you are taking how much time? To send one bit from your channel, you are taking how much time? 10s time. Therefore, bit travels here and here and here. For next 1 second, the bit is here. Second, the bit is here. Third second, the bit is here. Fourth second, the bit is here. Fifth second, the bit is here. Sixth second, here. 7 here. 8 here. 9 here. 10 here. Finally, it comes out. During this, sender will not be idle. Why? Because at every second he will send how many bits? One bit. So 1 bit per 1 second. That means when you send bit 1 and when this bit 1 moves to the next slot, then here it consists of what? Bit 2. And when bit 1 moves here, then automatically bit 2 will come here. Then you will inject what? Bit 3. Then when bit 1 comes here and remaining bits will be moving, so you will inject what? Bit 4. Likewise, if you observe carefully, at 10 different positions, 10 different bits you will get. How? First second, I injected how much? 1 bit. And the second, old bit and new bit. How many bits are there? 2 bits. Third second, previous 2 bits and a new bit. How many bits? 3 bits. And it goes on 10s. Now your pipe has how many bits? 10 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the first bit goes out. Again you can insert. Then second bit goes out. Again you can insert. Then third bit goes out. This is how I can calculate volume of the pipe. This is, I am talking only of duplex. You want double side insertion of the bits, sender as well as receiver, then the pipe size becomes what? Double. Okay friends, copy this. Yeah. Well, friends, I hope so. You got copied and understood what is the concept of volume of the pipe. Now you tell me, volume of the pipe depends upon only one parameter. That is what? Tp. Why? Just you will see like this. I am saying, for example, bandwidth is equal to 1 bit per second. Sender keep on send 1 bit for every second. Tp is equal to 1 second. So what is your BWDP? It's nothing but 1 bit per second into 1 bit, that is equal to 1 bit only. So 1s. So here Tp I restricted as only 1s. Therefore only you will find a 1 bit. If I am saying same parameters, bandwidth is equal to 1 bit per second and Tp is equal to 20 seconds. Now Tp is increased. Why Tp is increased? Because distance is increased. Now what is your bandwidth delay product here? 1 bit per second, and that bit takes 20 s to make a physical journey from one end of the media to other end of the media. So it is 20 s. Therefore how many bits you have? 20 bits in the pipe. Therefore, what do you understand? The bandwidth delay product or volume of the pipe or number of bits fit in the cable at an instance of time, it all depends upon what? Tp. Therefore, if distance increases, what will increase? Tp will increase. If Tp is increased, what will be increased? Bandwidth delay product will be increased. So reverse, if distance is decreased, Tp is decreased, then bandwidth delay product is also decreased. So it all depends upon the switching, depends upon only propagation time. If it is 1s, 1 bit, if it is 20s, you will have 20 bits in the channel. Okay friends? Our next parameter is calculation of link efficiency using the following. So now I am going to calculate link efficiency in this approach. That is, Tt is equal to 1 ms and Tp is equal to 1.5 ms, if I am saying. Now here, what is going to happen? What is the link efficiency? Here we are saying Tt by Tt plus 2 into Tp, 1 by 4. I can write this equation in different way, or if I am doing Tt up and down, then Tt will be placed everywhere. Okay. So Tt by Tt becomes how much? 1, and it becomes how much? 1. That is equal to 1 by 1 plus 2 Tp by Tt. If I am saying let A equal to Tp by Tt, therefore L of U equal to 1 by 1 plus 2A. So please, you have to inculcate this 1 by 1 plus 2A equation because it's mostly important for us. Okay, just copy this. Now you see how we did link efficiency calculation. Let's have a look at this, friends. The link efficiency calculation I did Tt by Tt plus 2 into Tp. I have written 1 by 1 plus 2a, where a equal to Tp by Tt. Okay, now I can also write in other style. What is the Tt? L by B, right? Now I am replacing L by B into that. Let replace L by B in Tt. Therefore, L by B plus 2 into Tp. Understand? So, what is the meaning of this? I can also write L by L plus Br. Why L by L plus Br? Here R is nothing but 2 into Tp. You get my point? So I can also write an equation like this: L by L plus Br, or R is equal to 2 into Tp. Now the famous equation among all the above is 1 by 1 plus 2a only. Okay, friends? Now you see calculation of frame size for 50% of link efficiency. So how to do this? That we do in such a way. So what is the link efficiency? The link efficiency is Tt by Tt plus 2 into Tp, or you can write 1 by 1 plus 2a. This efficiency is given how much? 50% is given. Now sort it out. Tt by Tt plus 2 into Tp equal to 1 by 2. So 2 Tt is equal to Tt plus 2 into Tp. Now Tt is equal to 2 into Tp. And now what is the Tt? Tt is nothing but L upon B equal to 2 into Tp. What he is asking? Frame size. Frame size means what is the value? L value. So how will you find L value? Therefore L is equal to 2 into Tp into bandwidth. That's it. Now, if I get this equalization, then automatically your efficiency, you are make it equal to 50% only. Okay, friends? That means if L equal to 2 into Tp, your efficiency is how much? 50%. If L less than 2 into Tp into bandwidth, then your efficiency is lesser than 50%. If L greater than 2 into Tp into bandwidth, then your efficiency is greater than 50%. This is how you can also calculate the efficiencies. So if you know the L value, then I could able to tell you the efficiency equations. So these are all efficiencies only. One efficiency is 50% and one efficiency is less than 50% and another efficiency is greater than 50%. It all depends upon your L value. This is equivalent to 50, this is less than 50%, this is greater than 50% link efficiencies. That means if I know the L value, then I can easily calculate the link efficiency, whether it is less than 50 or greater than 50 or equivalent to 50. Okay friends, copy this. Yeah, well friends, now finally what do we understand? If I know the L value, and bandwidth and TP value, we can decide what is the efficiency you will get. For example, as I am saying, bandwidth is equal to 10 Mbps, TP is equal to 20 microseconds, and we want to identify L is equal to 1000 bits. He is asking what is the link efficiency? Is it equivalent to 50 or greater than 50 or less than 50%? So the solution is, you know those equations. What is that? L equal to 2 into TP into bandwidth. You will come to know exactly 50% of efficiency. So if L greater than 2 into TP into bandwidth, we will come to know the efficiency is greater than 50. L less than 2 into TP into bandwidth, we will come to know the efficiency is less than 50%. Do it this, very simple. So what is that? L is equal to 1000 bits. Bandwidth is equal to 10 into 10 power 6 bps, because 1 MB is nothing but 10 power 6 bps, and TP is nothing but 20 microseconds. So 2 into TP into bandwidth we want to calculate. 2 into 20 into 10 power minus 6s into bandwidth 10 into 10 raised to 6 bps. So therefore this and this will be cancelled. 2 2s are 40, 40 into 10, 400 bits. Yes or no? So now you understand what is L value is given, 1000 bits. If 1000 bits greater than, tell me, 400 bits. Therefore efficiency, if L greater than this value, efficiency greater than 50%. This is how you can calculate, friends. Very easy. These are all the shortcut derived equations which you can't get from any other textbooks. So the idea belongs to is that using this equation, I can able to get what is L value, what is the TP value, what is the bandwidth value, what is the efficiency also I can able to measure using these expressions. Okay. Now let us do another. I am saying a question here. TT is equal to 20 ms, TP is equal to 40 ms, and what is frame size to get 50% of L of U? This is a question 1. Question 2. What is frame size to get 100% of L of U? Another question. What is frame size to get 60% of L of U? This is how you may get questions. Okay. Copy this, we will solve individually. And we also want to on bandwidth 10 Mbps, better 10 kbps. Yeah, well friends, now this time he is asking what is the L value to get 50% of efficiency. But in the old question, he is asking what is efficiency, either it is 50% or greater than 50 or lesser than 50, but he is asking reverse. By giving 50% of L of U, what will be the frame size? And 100% what will be the frame size? For 60% what will be the frame size? Now I am doing finding frame size for 100% of L of U. What is 100% of L of U? So L of U is nothing but Tt by Tt plus 2 into Tp. This is only your L of U. This is given to how much? 100% only. Therefore, I can use this equation directly. Yes or no? What is the Tp? Tt. What is the Tt is nothing but it is L by B by L by B plus 2 into Tp. I can write like this. Therefore, what is the equation? It is L by L plus Br. This equation you can write. So, since these values are given to me, what is the Tt value is given there? 20 ms is given by 20 ms is given plus 2 into 40 ms is given. So using that I could able to find 100% of L of U. But how will you find L value? He is asking what will be the L value. What will be the L value? We would like to know this equation. What is that equation is? Either you can write L by L plus Br, or you can write Tt by Tt plus 2 into Tp, or you can write 1 by 1 plus 2a. Anything you can write. So here I can write equation for L of U to get 100, or I can write 1 by 1 plus 2a equation, or I can write L by B plus 2 into Tp is nothing but L by L plus Br. These are all the equations gives what is efficiency? 100% only. So therefore all above equations generate L of U to 100%. From this we want to identify what is the L value. So we will see what is the L value to generate 100% of efficiency, either by using this equation or this equation or this equation. All the above equations are giving what is the efficiency percentage? L of U. I hope so you would like to know what are the L values to get 150 and 60% of efficiency. You have to stay tuned back. So we'll meet in the next session. Thank you.